Good early morning and welcome to the International Space Station's Flight Control Room. This is Mission Control Houston with live coverage of the arrival of a cargo spacecraft to the International Space Station. The Cygnus spacecraft is arriving with its cargo shipment in support of Northrop Grumman's 20th Commercial Resupply Services mission. It's carrying more than 8,200 pounds of supplies. And these are live views of Mission Control, but we hope to get live views of the Cygnus cargo spacecraft for you soon. Earlier this morning, Northrop Grumman engineers in Dulles, Virginia received a go to command the spacecraft to do its approach initiation burn. This burn is expected to begin in less than 10 minutes from now. This is an engine firing on the Cygnus spacecraft that occurs when the cargo craft is below and behind the space station. And with this burn, it puts Cygnus on an intercepting path to arrive at the point directly below the space station and into the neighborhood of the space station. Again, that burn is set to begin in about 8 minutes. The goal of this burn is to put Cygnus into the neighborhood of the space station and is to ultimately get into a position to be robotically captured and installed to the space station. Capture is expected at 4:20 a.m. Eastern Time, 3:20 a.m. Central. On your screen, we're getting live views of Mission Control. That is Flight Director Diane Daly in the lower right-hand corner of your screen speaking. She is our flight director in charge of all of the flight controllers in the room today. Also supporting this morning's operation is the Cygnus Flight Control Room in Dulles, Virginia, with Northrop Grumman engineers sending commands to the spacecraft. The Cygnus cargo spacecraft is 2,500 meters away from the space station. Once it gets a little bit closer, we'll get some good live views of the spacecraft as it makes its approach. We're about 6 minutes out from that approach initiation burn, and in the meantime, let's talk a little bit more about what this mission is all about. So today we're talking about the Northrop Grumman Cygnus spacecraft. It's on a mission to deliver cargo to the humans living aboard the International Space Station. Right now, it's catching up with the space station, getting closer and getting into a position to be robotically grappled for later installation to the Earth-facing port on the station's Unity module. The spacecraft contains dozens of science and research investigations that the astronauts will later unpack and begin working on later this week. And the spacecraft is scheduled to stay on board for 6 months before it's uninstalled at the end of its mission, burning up harmlessly in Earth's atmosphere. Cygnus does have the capability to reboost the space station, and if needed, it could be called upon to do just that during its 6-month mission. It launched aboard a SpaceX Falcon 9 rocket from Cape Canaveral in Florida on Tuesday, January 30th, so earlier this week. But we'll have more on that, including a recap of launch, just a little bit later. We're now about 4 minutes away from the start of the approach initiation burn. The Cygnus cargo spacecraft is about 2,100 meters away. We're back with live views from the International Space Station. Can't see the Cygnus cargo spacecraft quite yet, but it is getting closer and closer, and will hopefully be in our view very soon. So we already talked about who is supporting this operation here in Mission Control Houston under the direction of Flight Director Diane Daly. We know that we've got the Dulles control room too, keeping an eye on things. Our Capcom today is Alex Konotlenkos, and he's going to be serving as our Capcom, speaking to the crew. So if you hear that voice, there he is on the pink on your screen. So if you see a voice talking to the crew back and forth, confirming that they have good visuals of the spacecraft, that will be the voice of Konotlenkos. Meanwhile, up at the space station, it will be NASA astronaut Laurel O'Hara inside the space station cupola, who will be at the controls of the robotic arm today. There she is, right on your left there. That's NASA astronaut Laurel O'Hara. She's going to be in the station's cupola. And NASA astronaut Jasmine Mogbelli, on the right of your screen, will be there for the assist. Two minutes remaining until the start of the approach initiation burn on the Cygnus cargo spacecraft. The vehicle is now within 2,000 meters of the space station. "30 seconds until the start of the burn. And the approach initiation burn has begun. Again, this is a thruster firing on the Cygnus spacecraft. It puts Cygnus on an intercepting path to arrive just below the space station. The approach initiation burn is still underway on the Cygnus cargo spacecraft. We're in a momentary handover between our satellites. In the meantime, we'll stick with live views of Mission Control Houston until we can get those live views back. Should be any moment now. Less than 1 minute remaining until the conclusion of the approach initiation burn. Here in Mission Control, everyone reports that it is performing nominally thus far. And the approach initiation burn is complete. So with the completion of the approach initiation burn, the Cygnus cargo spacecraft is now 1,200 meters away.
2 for Cygnus approach.
With you on 2.
ADV3 approach initiation burn has been completed. Expect to begin using 1.102 Cygnus approach and retreat monitoring shortly when Cygnus range reaches 1,000 meters.
Okay, we copy. We're showing range at 1235 now.
We see the same.
So the voices that we heard just now are that of our Capcom here in Mission Control, Alex Kanalenkos, speaking to the International Space Station. That was NASA astronauts Jasmine Mogbelli and Laurel O'Hara. They're stationed in the space station's cupola at the robotic workstation. Cygnus is 1,100 meters away from the space station, and Kanalenkos was letting the crew know that once the spacecraft gets within 1,000 meters of the space station, that they can move on to their next steps. O'Hara has a list of procedures in front of her. This is the view from the robotic workstation here. This is the view that Laura O'Hara is getting. This is the data that she's seeing to help her robotically grab the spacecraft when it comes nearer. So she'll use a set of procedures there to robotically capture the Cygnus spacecraft, which right now is scheduled for an on-time capture of 4:20 a.m. Eastern Time, 3:20 a.m. Central. As we mentioned earlier, Cygnus is carrying more than 8,200 pounds of supplies, food, scientific experiments, hardware, and more. Some of the investigations include a surgical robot, a 3D cartilage cell culture, an autonomous semiconductor manufacturing platform, a 3D printer for small metal parts, and so much more. Many of the scientists and principal investigators of these science experiments participated in a science webinar before launch, so if you want to learn more about these investigations from the researchers themselves, I recommend checking it out.
Station Houston, Cygnus range is 1,000 meters. Monitor long-range approach per step 1 in 1.102 Cygnus approach and retreat monitoring.
Copy, step 1 and 1.102.
Good read.
And Houston, we have Cygnus in sight, and we show primary range at 950.
Copy, tally ho.
The Cygnus cargo spacecraft is now in the neighborhood of the space station. It is within 1,000 meters. That you just heard a NASA astronaut, Jasmine Mogbelli, speaking to our Capcom today. She is the assist for Laurel O'Hara, who will be the one to robotically capture the spacecraft today. This coordination is important because while we have all kinds of data on the cargo spacecraft and what we can see on our data screens, the actual visuals of the astronauts are important in this mission. The spacecraft will not be docked to the space station. This means that Cygnus will not park itself into an available port. Instead, it will undergo berthing operations. The robotic arm operator, NASA astronaut Laurel O'Hara, will capture the spacecraft at the controls of her robotic workstation. Then she'll hand over control to the robotic arm specialists here in Mission Control Houston.
Go ahead and 2, Marcus.
First, the payload laptop 3 was connected to the power chain, so that was intact, but the computer was turned off. And I assume that it was remotely switched off because I have not touched it since the orbital detector yesterday. Munich from station, I also want to report that the
and Marcus, Munich with you on 2, so that the payload laptop 3 was off is probably due to battery empty. And so, yes, please turn it on again for us. And thanks for reconnecting it.
And there we have it, live views of the Cygnus cargo spacecraft. Just a moment ago.
But on the other hand, it doesn't look like the computer is charging.
Earlier, our NASA astronauts confirmed that they had visuals. They were able to see with their own eyes outside of the station cupola windows at the spacecraft, and indeed we see it on our camera views as well. That's the Cygnus cargo spacecraft. No people on board, just cargo. We've got 8,200 pounds on board there at the center of your screen. The International Space Station is flying over the southern coast of Africa at the moment, and that is what you can see sort of through the clouds below the Cygnus cargo spacecraft. And there it is on your map.
7% battery remaining, so I don't think the battery was drained, but it's not charging, and the brick 1442 is powered on, and the output power light LED is lit green, and the power cable for Z-Book is connected, so I don't know why it's not charging.
And we copy, Marcus. Please, let's move over to Space Ground 3 to keep 2 for Cygnus.
Go, of course.
In less than 2.5 minutes, the Cygnus cargo spacecraft is set to perform another burn. This is just to further fine-tune its position to the International Space Station and is the last major burn of today's operation. Cygnus now closing in on 550 meters away from the International Space Station, and a burn is about to begin soon.
Station Houston, for all crew, Cygnus TRIDAR viewing constraints now apply. To prevent potential eye damage during Cygnus approach, cease using binoculars and DSLR cameras with uncovered viewfinders.
Copies.
The station has what's known as a common berthing mechanism. It's an attachment system used to mate segments of the U.S. side of the space station to visiting vehicles like the Cygnus cargo spacecraft. The common berthing mechanism is the installation port that Cygnus is guided into by robotics officers. There are hooks and latches to begin the process, and that is followed by the spacecraft being bolted into place. Here in Mission Control, the OSO mech, or the Operation Support Officer, directly oversees operation of that common berthing mechanism. This Cygnus will be installed into the Earth-facing port of the station's Unity module. One of the advantages of using a common berthing mechanism is that large equipment and cargo can easily fit through the opening. Just a short while ago, the Cygnus cargo spacecraft performed a final major burn to get the Cygnus cargo spacecraft into place, set for a robotic capture. The command to initiate this burn is sent by engineers in Cygnus's flight control room in Dulles, Virginia. We are in joint operations right now. This means that Mission Control Houston is working collaboratively with controllers in Dulles, Virginia on coordination of the burns and preparedness of the station crew to capture Cygnus for installation. The spacecraft is nearing into 400 meters away from the space station, but once it reaches 250 meters away, or about a tenth of a mile, it will stop approaching the space station. It will be commanded to hold at this 250-meter mark for a little over 10 minutes, and the two mission control rooms will pull go, no-go on this if the spacecraft can continue to move in. This is expected and planned part of our schedule today, and this is because the space station has an invisible boundary called the keep-out sphere.
Power cycle.
This keep-out sphere is a 200-meter radius, 200 meters in radius or 400 meters in diameter. You can get kind of a good view of that on your screen there. Sphere, perfect sphere around the space station, and it's one of the several safety zones for visiting vehicles like Cygnus.
I see green main power LED.
Copy, Satoshi. That's a good configuration.
So before moving within this keep-out sphere, Cygnus must be configured so that it would not cross that boundary for at least 4 orbits in the unlikely event that the spacecraft lost its maneuvering capability. Cygnus is inside 400 meters away from the space station, so there's a little bit of time before Cygnus reaches its next milestone at that 250-meter hold point. In the meantime, why don't we take a look back at how the spacecraft got here in the first place? Cygnus's journey to space began on a sunny Tuesday afternoon earlier this week. The spacecraft launched at 12:07 p.m. Eastern Time. That's 11:07 a.m. here in Houston on January 30th. Cygnus lifted off atop a SpaceX Falcon 9 rocket from the Space Launch Complex 40 at Cape Canaveral Space Force Station in Florida. It was an on-time launch for Northrop Grumman's 20th cargo resupply mission, and the first time a Cygnus cargo spacecraft has launched on a Falcon 9 rocket. You can see a recap of Tuesday's launch on your screen here. This is not a live view. The spacecraft went on to go through its post-launch milestones as planned. It separated from the Falcon 9 spacecraft with no issues and went on to deploy both of its cylindrical solar arrays a little less than 3 hours after takeoff. It's been making its way to the space station ever since. It went on to perform a number of delta velocity burns, some lasting up to 16 minutes, others lasting just seconds, all with the goal of fine-tuning the spacecraft's position in space to bring it to the space station. Mission Control Houston and the Northrop Grumman control room in Dulles entered joint operations, and about an hour and a half ago, both gave a go for another set of thruster firings. As you know, it did the approach initiation burn during our coverage today, and then another burn just a few minutes ago, and both performed nominally. The space station is inside 350 meters away from the International Space Station, again working towards its next milestone of going to the 250-meter hold point. We heard a little bit of chatter earlier with our NASA astronauts. NASA astronaut Laurel O'Hara is leading today's capture operation, backed up by her crewmate, NASA astronaut Jasmine Mogbelli. They're both stationed inside the station's cupola at the robotic workstation, and there are a number of tools at their disposal for a good capture this morning. So first, they're in the cupola. That's the part of the space station that has huge windows, and Mogbelli will serve as a second set of eyes for O'Hara during her capture. We've heard her call down to the ground a couple of times today as O'Hara focuses on her capture operations. They also have 3 monitors and can route various camera views and data screens to give them different perspectives while grabbing Cygnus. Sometimes we'll take those live views as well. Oh, you're looking at it right now on your screen. I want to bring your attention to the center right side of your screen. You can kind of see VV to ISS. That's visiting vehicle to ISS. Cygnus, of course, is a visiting vehicle. And you can actually see the number go down. It's 321 meters away from the space station and going towards that 250-meter hold point. So in addition to those 3 monitors with their camera views and data screens that they have, in addition to a number of controls right there in the workstation, they do indeed have what looks like a video game joystick. This operation is part of their astronaut training here in NASA's Johnson Space Center in Houston, Texas, where they can practice these controls in a simulated environment. But they also can practice at the real robotic workstation before Cygnus arrives to get a refresher on the controls while they're in space. And this is something that both Mogbelli and O'Hara got to do earlier this week on the station. The Cygnus vehicle is now within 300 meters of the space station. It's expected to get to its hold point in less than 5 minutes from now. We expect a call to the crew when this happens. So as Cygnus makes its way to the 250-meter hold point, Cygnus will seemingly stop in its tracks. But of course, it's not quite holding still. It's orbiting the Earth at thousands of miles per hour. But the rate that we're talking about is in relation to the space station. So it will not come any closer to the station than 250 meters. Like we talked about earlier, this is a good checkpoint before the spacecraft can enter the keep-out sphere. The keep-out sphere is 200 meters away from the space station, and it's an invisible safety marker. As long as Cygnus is outside of this boundary, we know that the spacecraft would not come any closer and damage the station if something were to go wrong. Flight Director Diane Daly in the room here with us in Mission Control Houston must give the go after polling her team before the spacecraft can begin to close in again. We're now less than 1 hour away into our planned capture of Northrop Grumman's Cygnus spacecraft this morning, but it's important to note that capturing the spacecraft is just the first step in the process. Once Cygnus is in the grasp of the robotic arm, the astronauts have completed their job, but the work then continues. It turns to the robotics officers here in Mission Control Houston to install the spacecraft. They will control the robotic arm from here on Earth using a camera that's looking out the Harmony module's hatch window as a guide, among other tools at their disposal. They'll guide the spacecraft to its final position at the Earth-facing port of the space station's Unity module. Then they'll install the spacecraft into place, permanently securing the cargo spacecraft in place until its departure 6 months from now. Cygnus now about 275 meters away from the space station, and we are in a brief handover period between our communication satellites, and we hope to get video of the Cygnus cargo spacecraft back soon. We're back with our live coverage of Northrop Grumman's 20th Commercial Resupply Services mission. That is the Cygnus cargo spacecraft on your screen there. It's making its way to the 250-meter hold point. This is a live view of Mission Control Houston. Also working this operation is Northrop Grumman's Cygnus control team in Dulles, Virginia. Once Cygnus reaches the 250-meter hold point, both teams will be performing checks, including of the vehicle itself on the Cygnus side, as well as making sure that the space station is ready to receive the spacecraft. And they must pull go. All the flight controllers that you see in the room here must pull go, and then our flight director will give the ultimate go to proceed past the 250 hold point and into the keep out sphere. We're just about 5 meters away from that planned hold. The spacecraft is almost at its 250-meter hold point. It's slowing its rate right now to get to that point.
Station Houston on space to ground 2 for Cygnus approach.
With you on 2, and we see the vehicle at 250 hold.
You are correct. Please confirm step 2 in 1.102.
Copy and work. And Houston from station, the command panel LED status matches. Primary range is 252 meters. And for Block Bravo, we have the light is within the corridor. The vehicle size matches the outline. The light is in monitor 1 offset from the circle about a quarter vehicle length forward and is centered on the circle in monitor 3, and the circle is offset from the corridor center in both monitors about 1 vehicle width starboard.
We copy, and it matches what we see on the ground.
Cygnus has reached its 250-meter hold point, and its approach is proceeding nominally. But this is not the only hold point in the procedures today. Cygnus will hold again when it reaches the 30-meter mark, or about the 32-yard line on a football field. And just like the hold that we're in now, Cygnus will need a go from the flight director to depart from the 30-meter hold point and continue moving in. Cygnus's goal today isn't to reach 0 meters on its own. It will be robotically captured when the spacecraft is about 10 or 12 meters away from the space station. Robotic controllers here on Earth will then move it to its installation port. We're inside 50 minutes until the expected capture time. In just a couple of minutes, Mission Control Houston will begin its go, no-go poll to see if they should proceed.
Station Munich on 2 for Marcus and timeline.
So we're still targeting a capture in about 45 minutes or so. But the Cygnus cargo spacecraft actually has plenty of other opportunities to be captured too. Everyone involved in the capture, so the astronauts up in space, the flight controllers here in Houston, the engineering team in Dulles, Virginia, they want really good lighting to be able to see what's going on. The space station sees a sunset or sunrise every 90 minutes, so they want to be in a cycle of good lighting conditions and have planned accordingly. The Cygnus cargo spacecraft is at its 250-meter hold point, and a go-no-go poll is underway here in Mission Control. You're getting a live view of Mission Control Houston as the go-no-go poll is underway. Each console position that you're seeing here will need to give a go in order for the cargo spacecraft to begin movement again and move into that 200-meter keep-out sphere. So here on the Mission Control Houston side, the team has pulled go, meaning that the space station itself is ready and capable to receive the Cygnus cargo spacecraft. We expect a call to the International Space Station crew supporting today's operation, NASA astronauts Laurel O'Hara and Jasmine Mogbelli shortly.
Houston Station 2 for WHC flash tank fill.
With you on 2, Satoshi. We are ready to proceed for your WHC fill.
Copy. I said go for step 2.2, proceeding.
The space station is now in an orbital nighttime, so our views of the Cygnus cargo spacecraft are not the best, but that is still the spacecraft that is the center of attention this morning for today's operations. That is the Cygnus cargo spacecraft at the center of your screen.
Station Houston on Space to Ground 2 for a status for Cygnus.
With you on 2.
And just letting you know that we're going to be here at 2:50 for a little longer. We're just doing some reconfig on one of the Cygnus radios.
Okay, we copy.
If you're just joining us, a Northrop Grumman Cygnus cargo spacecraft launched from Cape Canaveral in Florida on Tuesday, and now the spacecraft has arrived in the neighborhood of the space station. It completed a series of burn to get itself into the position that it's at now, the 250-meter hold point. So that's what you see on your screen there.
And Houston from station, we still see the light within the corridor. The vehicle size is about 25% larger than the outline in monitor 1 and 2. The 1 and 3, sorry. The light is not offset from the circle it matches, and the circle is still offset from the corridor center, about 1 vehicle with starboard.
We copy, and we have no concerns. Thanks for the status.
Flight controllers are now making sure that the spacecraft is healthy and ready to continue moving into a position where it can be robotically captured. Flight controllers also made sure that the space station is ready to receive the cargo spacecraft, having pulled that the space station is go just a few minutes ago. And NASA astronaut Laurel O'Hara with you on the comms just a short minute ago, confirming that even though the space station is in an orbital nighttime, she is still able to see the lights on Cygnus and has a good visual of the spacecraft. She is ready to receive the arm. Excuse me, she's ready to operate the arm and capture the spacecraft. At this point, the Cygnus engineers and Dulles are verifying that the spacecraft is working as expected and that the navigational hardware is working. I think on your screen, if you caught it just a minute ago, we got a little cameo from our astronauts. This is the view of the cupola. Laurel O'Hara and Jasmine Mogbelli are in the cupola with eyes on the spacecraft, both out the window and with the data screens that you're seeing there. That is the view that our astronauts are seeing as well. The Cygnus cargo spacecraft, it's still in its 250-meter hold point. Just earlier, Mission Control polled that the space station is ready to receive the vehicle, but we are in joint operations today. Mission Control is working very closely with Cygnus's engineers in Dulles, Virginia, who are performing a number of vehicle checks, including its navigational equipment and the overall health of the vehicle. Approach to the station is a deliberate choreography, and we're standing by for both teams to concur to move past the hold.
Station round 2, we received precaution prime, C2V2, loss of visiting vehicle heartbeat.
We copy. We're taking a look as well. No action for you.
Okay, Okay, copy.
Station Houston on Space to Ground 2 for a Cygnus status.
With you on 2?
Yeah, as you know, we were configuring some of our radios and that we had some just hiccups with the communication between C2V2 and the Cygnus radios. We are working to regain redundancy both on the Cygnus side and the ISS side for the radios.
Okay, we copy.
So you just heard our Capcom Alex Kanalenkos speaking to the crew in the cupola working today's operation. He noted that we are still at the 250-meter hold point for the Cygnus cargo spacecraft, and Cygnus engineers in Dulles are looking at slightly erratic behavior to the backup communication system. So they're hoping to restore that redundancy of communication on the spacecraft and the space station for this radio communication. At the moment, there is no impact to capture.
Station Houston on Space to Ground 2 for Cygnus and today's exercise.
With you on 2.
As we continue to lose a little on the timeline with the Cygnus activities, if you don't mind calling us before you hop on one of the devices, that way we can verify the exercise constraints, and that way we won't have to chase it all day long.
Okay, copy.
So you just heard a conversation between Alex Kanalenkos, our Capcom today, and the crew. Cygnus engineers continue to work to restore the redundancy in the communication system during this 250-meter hold. While we expect capture to occur as planned, we do expect capture later than originally predicted. We'll have a better handle on the capture time after we depart the 250-meter hold point. After the spacecraft has begun motion again, we expect about 1 hour until capture. The Cygnus cargo spacecraft had numerous capture opportunities built into its timeline today. And another go, no-go poll is being conducted to see whether the Cygnus cargo spacecraft is able to move past that 250-meter hold point.
Station Houston on space to ground 2, Cygnus and ISS are configured for approach inside the keep out sphere. Expect approach to resume shortly and stand by for Cygnus PCS command checkout.
Station copies.
As you heard communicated to our space station crew there just a moment ago, flight controllers here in Mission Control consulted with the engineers in Dulles, Virginia at Cygnus's control room and concurred that they are go to press ahead past the 250-meter hold point, but they're going to continue to watch that backup communication system on Cygnus as they press ahead. We'll get a better understanding of capture time. It's estimated to be about 1 hour after motion has started on the Cygnus cargo spacecraft again.
Station Houston, Cygnus has resumed approach. Go for Cygnus PCS command checkout. Hold arm per step 3 in 1.102.
Copy, step 3 in 1.102. Houston Station, hold command armed.
Copy.
The Cygnus cargo spacecraft is on the move once again. I want to bring your attention to the center right of your screen. You can see that VV to ISS.
Hold arm confirmed. Go for Cygnus PCS command checkout disarm per step 4 in 1.102.
Copy, step 4, 1.102.
You can see that number on the middle right of your screen, that 230. That's the distance, that's the meters away that Cygnus is from the space station. It has left its 250-meter hold point and is getting closer to get into a position for its robotic capture.
Houston
We expect
Station,
about an hour
hold
away
command,
until capture.
disarm.
Copy. Stand by. Station Houston, Cygnus PCS command checkout was successful. Begin monitoring approach from 250 meters per step 5 in 1.102.
Copy, step 5, 1.102.
Good read.
Cygnus is now within 200 meters of the International Space Station. It's difficult to see on your screen there. We've got kind of a data overlay, but the space station is in an orbital nighttime, so it's a little difficult to see.
Station Houston, Cygnus is inside the 200-meter keep-out sphere. Crew now has authority to issue an abort if no comm with MCCH and the light is outside the corridor.
Station copies.
The space station has an invisible boundary around it. It's in a spherical shape called the keep-out sphere, and that's at the 200-meter mark.
Houston Station, we show range at 186 meters. Light is within the corridor. Can't see the vehicle size relative to the outline. The light is offset from the circle, a quarter vehicle width forward, and the circle is offset from the corridor center, about half a vehicle width starboard.
We copy, no concerns.
So the Cygnus cargo spacecraft has moved past that 250-meter hold point, has gone on to pass through the keep-out sphere. This is that imaginary boundary, spherical in shape around the International Space Station at 200 meters in radius. It's gone through that and is now about 150 meters away from the space station. The next step is to do the same process at the 30-meter hold point. Cygnus will hold Teams here in Mission Control Houston and Dulles, Virginia will perform a number of checkouts and make sure that everyone is on the same page to proceed. Then they'll conduct a go, no-go poll, and if go, Cygnus will depart that 30-meter hold point, the same process that we just used for that 250-meter hold point a minute ago.
$145 meters, no change to Block Bravo. Houston Station, range is 130 meters, no change to Block Bravo.
Houston copies.
We're back with our live views of the Cygnus cargo spacecraft after a momentary satellite handover. The updated capture time is approximately 3:55 a.m. Central, 4:55 a.m. Eastern, but we'll continue to refine that time as Cygnus makes its way closer to the space station. At the moment, it's inside 125 meters away from the space station, making its way to that 30-meter hold.
Station on Space Ground 2. Range is 99 meters. Light is within the corridor. Vehicle size is about 25% larger than the outline. Light is centered in the circle, and the circle is offset from corridor center about half a vehicle with starboard.
Copy your block Bravo, no concerns.
Each Cygnus is traditionally named after a trailblazer in the aerospace community. This spacecraft is called the Dr. Patricia Hilliard Robertson. She was one of our own here at NASA's Johnson Space Center, a NASA astronaut, a pilot, and a medical doctor, originally selected to join the astronaut corps in 1998. She was training to go to the space station herself, but tragically lost her life before her scheduled flight. She was 38 years old. In addition to being this Cygnus' spacecraft's namesake, astronauts in Hilliard Robertson's class actually flew a photo of her and a patch with her name on it back in 2010. We're honored to welcome the Patty Hilliard Robertson Cygnus spacecraft to the space station. Like I mentioned previously, the SS Patty Hilliard Robertson is not the first of its kind. The Cygnus before this was named after another NASA astronaut, the SS Laurel Clark. Cygnus has more than 8,200 pounds of cargo on board. The bulk of the cargo is crew supplies, science experiments, and vehicle hardware, but the spacecraft also carries some spacewalk equipment and computer resources as well. When we're talking about crew supplies, this can mean food, hygiene supplies, maybe even some fresh clothes, anything that the crew might need to live comfortably in space. But there's also a number of experiments on board the Cygnus cargo vehicle today, and some focus on the fields of biology and physics. The first is called APEX 10, and it stands for Advanced Plant Experiments in Space, this one focusing on the plant-microbe interactions in space. It aims to understand how plants grow in the harsh environment of space. Many microbes that are normally associated with plants on Earth may actually improve the plant's ability to tolerate environmental stresses. This study aims to introduce plants in space to these beneficial microbes. It's being conducted on tomato plants to study whether microbe improves stress resilience and improves seedling growth of the tomato plants. And even though the astronauts aboard the space station exercise at least 2 hours a day, they still are at risk of bone loss while in space. One study aboard the Cygnus cargo spacecraft being delivered today investigates the effects of microgravity on a certain type of bone marrow stem cells called MSCs, specifically for their capability to secrete bone-forming and bone-dissolving proteins. Researchers hope to use this experiment to further understand bone loss caused by spaceflight. And a final biology experiment that I want to highlight today aboard the Cygnus is called BRIC-25, or the Biological Research in Canisters. It aims to understand how the spaceflight environment influences microbial growth. By studying bacterial behavior in space, researchers hope to not only protect the astronauts' health in space, but also understand bacterial adaptations on Earth. The Cygnus cargo spacecraft is now within 60 meters of the International Space Station as the orbiting lab moves into an orbital daytime, so our views of the Cygnus spacecraft are expected to get better.
All crew, to prevent potential eye damage during Cygnus approach due to TRIDAR, cease viewing Cygnus from all windows except cupola. Note that the approach will last till approximately 10:10.
Station copies.
This constraint starts at the 40-meter range.
Okay, copy. We're showing range at 56 right now.
We see the same on the ground.
Houston station range is 50 meters. Light is within the corridor. Vehicle size matches the outline. The light is centered in the circle, and the circle is offset from the corridor center about a quarter vehicle width starboard on monitor 1, and it is centered on the corridor center in monitor 3.
Houston copies.
While the Cygnus cargo spacecraft was at the 250-meter hold point, engineers in Dulles noticed a slightly erratic behavior to a backup communication system that has now been restored. Teams pulled go to proceed, and the vehicle began its motion again. It's now proceeding to its next hold point at the 30-meter mark, and it's about at that point right now. We're estimating a capture time at approximately 4 a.m. Central, 5 a.m. Eastern Time. We'll then go off the air and continue our coverage at 5:30 a.m. Central Time, 6:30 a.m. Eastern.
Station Houston on Space to Ground 2. Confirm 30-meter hold and set up for capture per step 6 in 1.102.
Okay, station copies, and we see hold and range is 30 meters, and we'll perform step 3 of 1.110.
Good read.
The spacecraft has reached its next major milestone, holding at the 30-meter mark. This is about 32 meters on 32 yards on a football field away from the International Space Station. It will not proceed any closer until a go-no-go poll is conducted here in Mission Control and is about to begin shortly. And the go-no-go polling has begun here in Mission Control, each of the console positions giving their go, ultimately leading to the flight director's decision to go past the 30-meter mark.
Copy. Stand by.
And here in Mission Control, the polling is complete. The space station is go to receive the Cygnus cargo spacecraft.
Station Houston on 2 for Cygnus approach.
With you on 2.
Yeah, Jaws and Laurel, we have one delta that we'd like to make you aware of. So because we saw the transient earlier with the C2V2 loss of visiting vehicle heartbeat, we want you, as you are trained, if you get that alarm, to go ahead and back away, but just take a little bit of break to see if it goes back out of alarm before you send the retreat. How copy?
Okay, we copy. So in the back away cue card, line 8, if we see, and this only applies to the time C2V2 loss of visiting vehicle heartbeat or all of block 8?
Good question. It's all of block 8.
Okay, for all of block 8, we will back away the arm and we will not send the retreat command right away.
Those are good words. Just a couple of seconds to see if it comes back out of alarm.
Okay, we copy.
Also, we'd like you to adjust the lab over the shoulder view. It looks like we came off the view there for a little bit.
Okay, I'll see if one of the other crew members can do that.
All right, Cygnus is ready to proceed to the capture point. Expect approach to resume shortly.
And with a go from Mission Control, Cygnus is
Station
on the
Houston,
move once
Cygnus
again.
has resumed approach to the capture point. Monitor approach within 30 meters per step 7 in 1.102.
Copy Houston, step 7 and 1.102, and we do see approach, and primary range is 28 meters.
Copy. And we have a good over the shoulder view. Thank you.
Copy, and for block Bravo, we see the light within the corridor, vehicle size matches the outline, light is centered on the circle, and circle is centered on the corridor center in both monitors.
Houston copies.
So just as the spacecraft did at the 250-meter hold point, it held again at the 30-meter hold point and got the go from Mission Control to move past and is now on the move once again, now 25 meters away from the space station. As a reminder, its goal is not to get to 0, but to kind of hang around the 10 to 12 meter mark, where NASA astronaut Laurel O'Hara will use the space station's robotic arm to grab the spacecraft. NASA astronaut Laurel O'Hara will use the robotic arm that you see on the left-hand bottom corner of your screen. That is the robotic arm in today's operation. It's called the SSRMS, or the Space Station Remote Manipulator System, or simply the Canadarm2. At the end of Canadarm2 is what you may hear referred to as a lee, or a latching end effector, which is basically the hand of the arm. Inside are latches and snares that can grab onto and capture a target. Today, NASA astronaut Laurel O'Hara is controlling the robotic arm with an assist from NASA astronaut Jasmine Mogbelli. You heard a brief conversation a minute ago between Capcom Alex Kanalenkos and our astronauts on some instructions that they see on their procedures today. When O'Hara is ready, the latches will engage and grab on, and the latching end effector has a camera, so sometimes the view that you will see on your screen will be from the robotic arm itself, but we don't have those views just yet. The spacecraft is now within 20 meters of the International Space Station, making its way to its capture point. Mission Control will give one final go, no-go for capture. While delivering cargo is Cygnus's main job, it also serves an important function for the space station at the end of its mission. The astronauts on the space station cannot just go take out the trash wherever they want to. They have no shower and no washing machine for their clothes, so Cygnus is loaded with wet wipes, old clothes, gloves, food wrappers, anything the astronauts don't want around their house. At the end of its mission, Cygnus burns up in Earth's atmosphere, essentially eliminating its onboard trash, so it's very great to have after all of the cargo is unpacked. The engineering team at the Northrop Grumman Center in Dulles, Virginia, are conducting a go, no-go poll now. Cygnus is now 15 meters away from the International Space Station. You see the spacecraft there with its cylindrical solar arrays on the right of your screen and the robotic arm at the left of your screen. We're now less than 15 minutes away from Cygnus's robotic capture time. Of course, these times are approximate and will update with the actual capture time live on air. And Cygnus has arrived at its capture point. The view you're looking at is down the barrel of the robotic arm on the International Space Station. So NASA astronaut Laurel O'Hara is there at the controls of the robotic arm in the station's cupola. The spacecraft has a number of aids to kind of help her out. We talked previously about how the cupola has a number of data screens to kind of help inform O'Hara. She can also look at it. NASA astronaut Jasmine Mogbelli can give her another set of eyes as well. But there's another tool on the spacecraft itself. It has a grapple target that O'Hara can use to correctly position the station's robotics arm. So we can see it right now on your screen. It's a little in the distance. It's in the middle of your screen. It's a black bar, kind of parallel with the bottom of your screen. It's a black bar with a white line there. But that's not actually what she's going to be grabbing onto. O'Hara's goal is to grab the grapple fixture, or the pin, sticking straight out perpendicular underneath that black bar. The robotics arm's latching end effector, or its hand, has a special snare mechanism that can grab the grapple pin and firmly hold onto it. So that grapple fixture, the pin, is what O'Hara is aiming for today, while the grapple target, the flat white line, will help her.
Station Houston, confirm capture point hold for step 8 in 1.102.
Houston Station copies. Executing step 8 of 1.102. Houston Station, capture conditions confirmed and crew ready for Cygnus capture.
Stand by for capture.
And NASA Flight Director Diane Daly just gave the go. Cygnus is ready for capture.
Station Houston, go for Cygnus capture sequence. Step 4 in 1.110, Cygnus capture. Begin monitoring the backaway cue cards.
Copy. Go for step 4 in 1.110 and monitoring the backaway cue card.
Cygnus is at its capture point right now. It is 12 meters away from the space station and not moving. Shortly we should see movement with the robotic arm. Laurel O'Hara confirmed that she is ready to capture the spacecraft. Operations to robotically capture the Cygnus cargo spacecraft is underway now. The space station has moved into a configuration known as DSATs inhibited. Essentially, the space station has gyroscopes that help keep it in the correct position. And when Cygnus is being captured, flight controllers don't want the gyroscopes thinking that the space station's orientation is going out of whack, initiating those thrusters, so they're temporarily inhibited during this operation. The robotic arm is in motion towards the Cygnus cargo spacecraft. The view that you're looking at is just down the barrel of that robotic arm. The robotic arm is 2 meters away from the spacecraft. Closing in now for capture. Robotics officers reporting that the operation is going nominally. The robotic arm is going through the procedures to grab a hold of the Cygnus cargo spacecraft. We're in a brief but expected handover period as the robotic arm of the space station closes on the Cygnus cargo spacecraft. Laurel O'Hara is at the controls in the space station's cupola, doing a capture of the Cygnus cargo spacecraft today, and we hope to get our live views back of that operation shortly. This is a brief but expected handover. Meanwhile, here in Mission Control, robotics officers are monitoring the behavior of the robotic arm. Laura O'Hara is at the controls, but they can see data from the robotic arm. We're still waiting for the latches to close, but everything is performing nominally. And the latches are in motion.
Station on to Cygnus capture complete. Go for Cygnus post-capture reconfiguration.
Congratulations, capturing NG-20, 3,726 kilograms of cargo, including numerous crew provisions and research like 3D printing, semiconductor manufacturing, and remote robotic surgery demonstration. Welcome to ISS, Cygnus.
Thanks, Alex. And on behalf of the Expedition 70 crew, we'd like to congratulate the Northrop Grumman and NASA team on a successful launch and capture. We know it takes a huge amount of dedication and effort to make these missions possible, and we appreciate all that you do to ensure success. We're excited to welcome the Cygnus SS Patty Robertson to the International Space Station. Jaz and I did not get to know Patty personally, but we've heard so much about her, and we know we would have loved to have her as a crewmate on Space Station. It's an honor for all of us to play a part in carrying her legacy forward. So again, congratulations, and thank you all for your support.
Those are great words. We appreciate them.
And there you have it. We have confirmed capture of Northrop Grumman's 20th commercial resupply mission at 3:59 a.m. Central Time, 4:59 a.m. Eastern. At the time of capture, the SS Patty Hilliard Robertson Cygnus and the International Space Station were flying over southern Russia. So to recap the events, Cygnus lifted off atop a Falcon 9 rocket on Tuesday, January 30th. It successfully performed a number of burns to get the spacecraft to all of its checkout markers. First, the 250-meter hold. Here, teams noticed an issue with one of its backup communication systems, and the issue was resolved. It went on to the 30-meter hold and finally into a position for NASA astronaut Laurel O'Hara to robotically capture the spacecraft at 3:59 a.m. Central Time, 4:59 a.m. Eastern, as the station was flying over southern Russia. The spacecraft contains more than 8,200 pounds of scientific experiments, crew supplies, spacewalking equipment, and other cargo. This concludes our coverage of rendezvous and capture of the SS Patty Hilliard Robertson Cygnus cargo spacecraft, but we'll be back on the air at 5:30 a.m. Central Time or 6:30 a.m. Eastern. When we come back, flight controllers here in Mission Control will be working to install Cygnus to the Earth-facing port on the station's Unity module. This is Mission Control Houston. We'll see you then.